Hey guys, welcome to your last video of your pre-AP pre-calculus life. So today we're going to talk about one last thing about derivatives, and it's called the quotient rule. So it's kind of like the product rule, but now we're dealing with two functions that are being divided. And so this is what the quotient rule looks like. If I'm trying to take the derivative of some fraction-y function where there's a part on a numerator and a denominator, you're going to follow this. And I have a little kind of acronym or whatever. This one, if you see this right here, g of x is your low function. So I have a low function, and then I have what we call a high function. The one on top is the high function, the one on the bottom is the low function. So this is low, and then the derivative of the high. So we find the derivative of that high using either my power rule or something else. And then I would have minus high d, the derivative of the low, all over low squared, or low times low. So again, it's low d high minus high d low, all over low. And it takes a little bit of work, but again, you're not going to be expected to simplify too much here, as long as you understand the concept of when I take the derivative of something that's being divided, I followed this formula. So let's do an example. So here's this first one. We have f of x is equal to x squared minus 1 all over 2x plus 1. And there's really nothing that would cancel out here, even if I tried to factor. So I'm just going to go ahead and find that derivative. And so again, I can do just like I was doing with the product rule, and I can name my functions. I'm going to call this one f of x and this one g of x. And I'm going to go ahead and off to the side, I'm going to find the derivative of that top function. So this is d high. And again, it's just the power rule. Bring down that coefficient, or that exponent, make it the coefficient, subtract 1. And then I'm going to take the derivative of my bottom function, which is just going to be 2. And so now I'm going to apply that formula. So I want to find the derivative of this entire function, and it's going to be pretty long. So I'm going to have low, struggling here, my g of x. So I'm going to take that whole function, d high, so the derivative of the top, minus high, so the whole top function, which is blue for me, d low, which is the derivative of the bottom, which we said was 2, all over low. So I'm going to have 2x plus 1 quantity squared. Okay, and this is pretty much, I would be really great if you got to this point. But if your answer choices were simplified down, you would have to go through and do a little bit of FOIL, etc. And just for sake of time here, I'm not going to do that. This is just algebra at this point. But this guy would be the derivative of this entire quotient of those two functions. Okay, now, sometimes when you see a fraction, you get tempted to use this quotient rule. And as fun as that might be, you may not have to use the quotient rule. If I look here on number 2, f of x is equal to 3 over x to the 4, I noticed that I could rewrite this using my exponent rules. This is just 3 times x to the negative 4 power, because anything on the bottom had a negative exponent. So now at this point, I can just pretty simply use my power rule instead of going through and having to do this low d high business. So if I just do my power rule here, I'm going to take my 3 and multiply it by the exponent, so negative 12. I'm going to subtract 1 from my exponent, so I'd get negative 5. And then if I clean that up a little bit, I would have to move my exponent down there, or my x down there, and that would be my derivative. So you don't always have to use your quotient rule if you can recognize a couple exponent rules, just like on this next one. If you look here, f of x equals 4x squared over x to the 2/3, you have the same variable with just different coefficients. And if you know your exponent rules, I said coefficients, with different exponents. So right here, I know that I could just subtract my exponents if they are being divided like this. So really what I have here is 4 times x to the 2 minus 2/3. And so now I can just play a little bit of the common denominator game. So this would be 6 over 3 minus 2 over 3. So I'd have that my function is actually equal to 4 times x to the 4/3. And now that's pretty straightforward for me to go ahead and just use my power rule on. I go ahead and I multiply 4 times 4 over 3. And then I'm going to subtract 1 from my exponent. And remember, 1 is equivalent to 3 over 3, common denominator there. And so what I have it's going to be 16 over 3 times x to the 1/3 power, or I could have written the cube root of x. Okay, and so that's all I had to do for that. I didn't have to try to worry about doing my power rule a bunch of times. Just had to remember my exponent rules. Okay? And there's one last thing that's kind of interesting about derivatives, and it's kind of the same thing like we did with limits. So if I look here and I have some number multiplied by a function, say that was like a 4. If I'm taking the derivative of this thing, it would be the same idea as if I took the derivative of that crazy function and just multiplied it by the constant. That's going to make your life a little bit easier, and again, make it so you don't necessarily always have to use the product or the quotient rule. So if I look at number 4 here, it looks like it's being divided by something, but really this is just some number. Really what I could do here is multiply by 1/5, and that would be the same thing, multiply this function by 1/5. And so what I'm going to do here in order to find my derivative is I'm going to worry about that 1/5 later. And then I'm just going to find the derivative, which again I can note a lot of different ways, of this function, this 3 square roots of x minus 2x, because then I don't have to worry about any denominators or any crazy fractions. So I'm going to go ahead and look for that derivative. Remember, this one is just x to the 1/2 power. So if I go ahead and find that derivative, I'd have 3 x to the negative 1/2. I have to subtract that exponent. Oh, 3 times 1/2. Whoops, I lost my 2. I'll put it over 2. Okay, and then minus 2. And then I could just do a little bit of making this prettier. So I'd have 1/5 times 3 over 2. Remember, your x is going to go down to the bottom. I'm just going to make it a square root. And then I could go through and distribute that 1/5 as well. Okay, but again, you don't always have to use the quotient rule. Now number 5 is a point where you do have to use the quotient rule though, because if I look here, I have some function on the top, I have some function on the bottom. I could take that 3 out, that would be okay, but it wouldn't really, or the 3 in the bottom, but it wouldn't really change what I have to do here. So I'm going to say that this top part again is my high, or my f of x, and be careful here, because if I wanted to find the derivative of this is actually 2 functions multiplied together. Oof, so I have to use my product rule on this one. So I'm going to take my first function times the derivative of my second function, so negative sine x, and then I'm going to add the derivative of my second function, which would be 2x, times my first function. Okay, so that would be the derivative of the top. Now, the derivative of my bottom is a little bit nicer, because that's just 3 times sine x, so 3 times cosine x would be that derivative. So now I can do my high d low thing. So I'm going to have that the f prime of x, the derivative of this entire thing, is low, so 3 sine x times the derivative of the top, low d high. I'm going to make this a negative. Wait 1 second, I'm going to erase some stuff. I feel like I'm going to run out of room. Negative x squared sine x plus 2x cosine x. So this is just low d high, plus high, which is x squared times cosine x, and then d low, so high d low, 3 cosine x, all over low low, so 3 sine x quantity squared. Okay, and this would be, I would be pretty pleased if you got to this point, because that was a lot of work. You could simplify this down a little bit and distribute your signs and distribute this x squared cosine x, and you'd also you'd find some things cancel out really nicely. The one big thing here is to remember down here on the bottom, this is 3 sine x squared, and so the denominator is actually 9 sine squared x. Be careful how you write that, or leave it into parentheses like this. But again, I would be more than pleased if you got to this point with that crazy quotient rule. So, moral of the story here, we have this guy, which is if you're trying to take the derivative of some quotient of something being divided by another function, you're going to have low d high minus high d low all over low low.